Welcome to Walkabout the Galaxy, the year-round astronomy podcast where the science is universal, the opinions are personal, and the hosts are almost finished with grading. I said finished with grading, but then I found out it's not actually the case for all of us. No. We are Strange, Charm, and Top the Astroforks, also known as Josh Caldwell,
Addie Dove,
and Jim Cooney,
coming to you from the satellite Walkabout studio near the University of Central Florida. Remember to check out our website to see how to get our snazzy shirts and subscribe to us on all platforms. Our stumpers today are NASA Administratorial.
No.
Oh,
You're the NASA administrator. And
Congratulations.
And Congress has inexplicably given you two amazing choices.
Okay.
So these are going to be funded no matter what they cost.
Okay.
You can do them, but you can only do one of them.
Okay.
And it's exclusive of everything else.
Okay.
Addie, establish a permanently tended base on the moon for the next 25 years with no human expeditions to Mars in that time frame. Or a series of Apollo-like short-term visits to Mars over the course of the next 25 years, but no people going to the moon.
Ooh, tough one.
I'm going to go moon.
I figured you would go moon.
Partly because, if we're going to be honest,
Yeah.
there's not going to be many human expeditions to Mars in the next 25
in this
years
case,
anyway.
though, in this case, you have
Somehow,
this
would happen.
It would
there would
happen.
be Apollo-like
You
trips
would have
to
at least
Mars.
6
Yeah,
landings.
I'm
And
still
they'll
going to
say
go
they'd
moon.
be there for at least a month each time.
I'm still going to go moon.
Okay.
It's a hardcore love of the moon.
Well, also Apollo-like trips to Mars are just like
And
not
what?
not
Then
practical.
at the end,
And like, what's the? I think the future of, I think if we want to continue exploration, I think Apollo-like trips are not
the way to go.
the way to go.
Mm.
And it's hard to do Apollo-like trips on Mars because of the time and the distance to get there. The distance it takes, like, even if you stayed for a month, it's not really. You might as well stay for 6 because.
But you can't think about
No, I
being
know.
hard. In
Well, I
this
can.
case.
I can.
In this scenario, it happens.
Sure,
regardless
sure.
of how hard it is.
Sure, but
Title
like.
of my sex tape.
Oh, jeez.
But I just don't. I like the long term. Because I like the idea of having a long term plan, having long term operations happening.
I'm with you.
I like it.
I'm with you on that. I think
we can
thinking
keep
long term
Mhm.
for humanity's exploration off planet Earth, permanent presence,
somewhere.
and the moon is such a great stepping
It's
stone.
so great.
It's a great stepping stone. Jim,
Mm-hmm.
build an AU scale, astronomical unit, Earth orbit sized scale, gravitational wave observatory in space, or a giant, and I don't know how big, but big enough to do whatever I'm about to describe,
Uh-huh.
space telescope with, at a giant distance, also in space, occulting disk, essentially, to
Star shape.
allow real direct imaging and characterization of extrasolar planets.
Interesting.
And other cool things.
No, you can only do that.
Okay.
Congress was just,
Explicit.
they were very explicit, very particular.
I'm going with the Gravitational Wave Observatory.
Yeah.
Just because, for one, it's just so new and interesting. We're not even sure of all the cool things we could learn. I think with an AU-sized, we're very well funded because that's what's going to happen.
Right.
Gravitational Wave Observatory, you know, obviously now we're real limited because you can only see things that produce copious gravitational waves.
Between Washington and Louisiana.
But this thing, you could really, yeah. I mean, those arms are 4 kilometers. If you had an arm that was an AU, man, you could see some awesome things.
So what kinds of thing? What would you see? Because it's all about these. Is it that more sensitivity, or is it a different frequency?
Well, I think both.
Okay.
I think both, and both are important, right? Because the signals that you are seeing are fairly high frequency and fairly high amplitude that we are seeing with the current ones, but we could see lower frequencies and lower amplitudes with this much bigger thing, and so you could see white dwarfs colliding together just
Yeah.
before they go supernova or something like that. Whereas you can't see something like that now. Now
Oh,
the
yeah.
other one is cool too, but I feel like we have some tricks for characterizing these things, like analyzing the atmospheres of those things and stuff like
Yeah.
that we're on the verge of being able to do now anyway. So I don't think we need that big scope.
I would go with the exoplanet one.
Big
this
star
one.
shade.
Yeah.
Alright, that's fair.
I like a big star shade.
Yeah.
Concept, at least.
Yeah, that's what. But in any event, well, today we'll talk about Saturn's chewy center, the Milky
Delicious.
Way's antimatter fountain.
Also delicious.
Yeah, it only takes 3 licks to get to the center of each.
Nice.
Interesting.
Uh,
Your tongue just dissolves.
yeah.
Antimatter fountain.
Some interesting space news. But first, this episode of Walkabout the Galaxy is brought to you by Confidence Interval. Have life's uncertainties knocked you back on your heels? If you find yourself shaken and unsure about what's coming next, maybe it's time for you to take a break in the confidence interval. Setting clear boundaries for what you can really count on, the confidence interval can help you relax with the knowledge, the confidence, that things have a 95% chance of working out as advertised. And if you need more confidence, you can upgrade for a nominal fee to our 3 sigma, 4 sigma, and even 5 sigma models,
Wow.
providing you confidence intervals as large as 99.999965%. Find your footing again with confidence interval. Confidence interval, because change happens.
Oh. Change happens.
I'll
That's
give you
the
a useless
motto of,
clue,
like,
which is that happens is spelled with a Z instead of an S at the end.
oh,
Oh, jeez.
I don't care what it is now. I don't like it.
Traveler's insurance.
Oh my gosh. Very, very close.
Oh.
It is an insurance company, Zurich
Oh.
Insurance Company. And that's Zurich is why it's with a Z.
I was going to guess
instead of an S.
Zillow. Because it's
That's
Z.
also good.
And
Okay.
there's a
Yeah.
change.
I
My
think
first guess was
combining the
interstate
two-
toll system.
Oh, okay.
where change happens.
Right.
Oh, right.
Well, combining the two, you got the Z, you got the insurance. I think you win.
All right.
By our powers combined.
Yes, that's why there's 3.
We're one reasonable person.
Yes, that's what it takes. Takes a
Yeah.
strange, a charm on the top.
And the answer
make
to how many
one
astrocorks
reasonable.
does it take?
to make a reasonable person.
Yeah.
There's probably some deep truths in there.
I think so.
Mm-hmm.
Some cancellations, like some positive charges and some negative charges.
Mhm.
Balancing things out.
I'm
So
most of the positive charges.
you do what?
I said I'm most of the positive
You're
charges.
most of the positive charges, but you can have too many positive charges.
It's true.
The Crew 1 mission watered.
Splashdown. Nighttime splashdown.
Who does that one?
SpaceX.
And NASA.
SpaceX. Okay.
It's
The
SpaceX's
SpaceX capsule.
vehicle.
It's
Okay.
a NASA mission.
Are you
NASA
confused?
hired them.
Yeah.
Yeah.
Yeah. No, that's a good question. Yeah, it was a SpaceX capsule, the Dragon capsule, splashed down.
First human splashdown since 1968, Apollo 8.
Yeah.
At night.
At night.
Sorry.
It's okay. First
At
human
night.
splashdown since the last the crew demo mission,
Right.
I guess.
Yeah.
Yeah.
So these are the guys coming off of the
ISS.
ISS.
So now there's only 8 people on the ISS.
Yeah.
Still
enough
A
for
nice
a party.
compliment. Yes.
You could still play some fun party games
You
up there.
can. You
Mhm.
can.
And I bet they are.
Oh, totally.
Do they all are they all on the same sleep-wake schedule when they
No,
have
I don't think so.
that
I think they shift slightly.
can have some shifts? Yeah.
Yeah, that was exciting that they came back. It got postponed a few times because of weather, but then they made it back.
Yep.
Good job.
Excellent.
And speaking of space companies,
SpaceX.
Well, so
SpaceX
sticking with
specifically.
SpaceX had some other news this week.
The SN15, serial number 15 version of Starship, which is this old-fashioned rocket-looking thing.
The Flash Gordon
The
rocket.
Flash Gordon rocket that hops up and then comes back down actually did that. It hopped up and it came back down and there were no explosions.
And it didn't. It was still had a fire going at the
Yeah.
end, which I guess wouldn't be a problem on the moon because there wouldn't be any oxygen,
It's true.
presumably.
It's true.
But yeah.
I also think that's a feature they'll eventually get
They
rid
kind
of.
of maybe they can work on that whole still burning
Still-
anti-land business. And yeah, so it didn't blow up or take off again or
No.
anything like that.
It was a hard one to watch because it was in clouds most of the time
Yeah,
and the feed cut out
the video feed wasn't great.
suspiciously.
Why do you think they skipped serial numbers 12, 13, and 14?
I don't know.
I think they were skipping 13 and giving it a margin.
A confidence
they didn't
interval.
want to be. Yeah, that's right. They didn't want to be like too obviously skipping 13.
Like the row on the airplane where they skip 13 and you're like, that just means the next row is 13.
Mm-hmm.
That's not how that works.
Yeah.
They skip weird rows on planes though sometimes anyway.
Yeah. But on the other billionaire space company news,
One of them.
there's real. Yeah, I guess. Yeah. Blue Origin announced on May 5th their date.
They really should have done it on the 4th.
Yeah, I think the 5th is an anniversary of something.
It's probably true.
And they announced that their first launch of people on their suborbital rocket, the New Shepard, will take place on July 20th, which is definitely an anniversary of something.
It is. Moon landing.
First time people
humans on the moon.
And so presumably that capsule is going to have.
Talking about this year, right?
Yeah.
Yeah.
This year.
I knew it was going to be in
months.
July because my other flight got pushed back. So I knew, I was like, well, and because of the cadence, we talked about this last time, right? The cadence, they've been going like every 3 months-ish. So it was like, maybe it'll happen in July.
So in July. But
I
what
didn't
you
know.
said.
July 20th, 2021.
Right, okay,
They
so.
have announced that they are going to take off with people on their rocket, which has launched a dozen or so times.
Right.
And most of those people, all but one, if I'm understanding things correctly, are probably going to be Blue Origin employees or
They're astronauts, yeah.
they're people to sort of work out the systems, but they're auctioning a seat to the highest bidder.
So if anybody wants to bid
And
for
you can
us,
bid now.
That's such a short time to get ready mentally.
there are people who have been mentally preparing to do this for quite
a
some
long
time, though.
All right.
Yeah.
So what do you guys?
What are we going to
do
bid?
you have any money? I have in my wallet right now $5 US.
I just spent all my money on a kitchen. I also have zero cash money in my
Jim's the
wallet.
highest
All right,
bidder
five.
on advanced
So far,
reports.
5.
Yeah,
So far,
good
5
job.
is the highest. I might win.
The first part of the bidding is sealed online bidding, so you won't know how much other people bid.
Put in a $5 bid.
Yeah, and then they open it up on May 15th or something for some. I don't.
May
totally
19th. It's sealed from the 5th to the 19th. You can bid any amount you want on the auction website. And then on the 19th, it's unsealed. The bids become visible, and participants must exceed the highest bid to continue in the auction.
Okay.
And then
I don't understand the point of the sealed
I don't
portion.
either. I don't understand how auctions work because I'm not in that life.
So it's a little bit interesting.
But it's exciting.
It is exciting. So
And they're announcing June 12th the bidding concludes with a live online auction.
So I'm giving our
I
listeners.
hope they have a good auctioneer.
Oh yeah, that would be amazing.
Yes.
Going once, going twice. For our listeners, if you're listening to this relatively shortly after we release it, if you post or send an email to WTG at UCF.edu with your guess for what the winning bid will be, then we will double your bid. No. We will put you in a drawing for a free Walkabout the Galaxy t-shirt, which is the best we can offer. Take it or leave it.
Yeah.
Yeah.
But you need to get us that guess by May 31st. I had to pick some time before the bidding ends.
Well,
But
no, you have to.
The bidding has already started, and it'll be visible, but whatever. So you'll have some information. If you wait until May 31st, you'll know
I think you have to do it by
something.
May 19th.
I don't know if anybody will hear this by May 19th.
Oh, okay. How about
I don't know if
May?
anybody will hear it by May 31st either.
Okay.
Yeah.
That's fine.
I'm happy to give
It'll
away
give you a
t-shirts.
lower limit.
That's right. That's right.
If you wait until the
People
end.
will pay
so.
attention.
Yeah.
Right. So there's that. The other space news, there was the European Geophysical Union meeting last month in Vienna, except it was virtual. And
Oh, that's so disappointing.
yeah, and one of the presentations there was about a proposed mission called the Interstellar Probe mission.
Oh yeah, I've heard a little bit about that mission.
Yeah. So it's sort of coming from Johns Hopkins. And we've talked in previous episodes about how the Voyager spacecraft and now New Horizons is heading out there.
Pioneer as well.
And Pioneers are out there, although we're not really getting the same quality
Right.
of,
We're not
of
talking
data
to them. Yeah.
that we're getting from the Voyagers. Voyager's actually making scientific measurements still at 100 times farther away from the sun than the Earth is.
It's pretty cool.
That's
where the sun's magnetic field and the sun's plasma is sort of blending into the interstellar magnetic field and plasma. But it took, the Voyager's launched in 1977. 78, 79, 80, I get 34 years.
So long.
And so that's a long time to get out there.
Did you get 34 years?
I did get 34.
Okay.
21, no I didn't, 44. What year is this? 1921.
I thought we were doing a thing with
some.
like that's how old I am.
That's right. Well, that is what happened. That is how old I am, and that's why I said 34.
Exactly. Yeah. You're like,
44.
oh, it's the same age as me.
I was just thinking back to when it was 2011.
Right. Good times.
Those were good times, actually. But not for you, Addie.
You're fine.
Not as good. Those were good times for me.
I would say something, but it'll make you feel bad, so I won't.
Yeah, because you were so young. You were just a kid. In any event, that was 44 years to get 100 times farther from the sun than the Earth. So with the new NASA Space Launch System, which is a heavy with a capital H lift vehicle.
There's an update on that too, is that the core stage got to Kennedy in the last couple of weeks, and they're starting to integrate everything.
Putting it all together for launch
together
later
a
this year,
NASA
right?
rocket. Yeah, hopefully.
Yeah, without people on board, but the next flight after that would have people.
Yeah.
And that rocket has got a huge lift capacity, which means if you put a little tiny rocket in it, you can get it going really fast.
Nice.
And so they're basically proposing that you could do something like the New Horizons spacecraft, which flew by Pluto, and launch it in a hell of a hurry. And then you could make measurements out to like 4 times the Voyager's current distance, so like 400 times the distance of the Earth from the Sun. Still take decades.
Yeah.
Talking about like a 40 to 50 year mission. So the people who are dreaming all this up, will not see the end of the mission, although it could launch in the next 10, 15 years.
Yeah, I think they would expect it to hopefully launch sometime in the 2030s.
It seems a little bit ambitious to name it an interstellar probe.
Well,
Why?
it's a journey
even
into
400
interstellar
AU
space. And I know
I
we've
guess
talked
so.
about this before
Yeah.
about
And you don't like it.
but it's interstellar in every sense except the gravitational sphere of influence.
Right.
Yeah.
Right.
So all of the sort of space physicsy stuff,
Right.
which is plasmas,
Which is the good
fields, charged particles, all of that stuff is interstellar at those distances. But you're right, there's still all sorts of objects orbiting the sun out there.
Yeah. You're still,
And a whole bunch of objects orbiting the sun much, much further out from that as well.
right.
Yeah. So that'll be something to keep our eyes on.
Yeah.
If that
Yeah.
It's
happens.
exciting to see SLS starting to finally come together too.
Right. Yep. Big rocket.
Big rocket.
Speaking of big rockets, I give it
As we
sort
do.
of lead into what our trivia will be. Maybe I'll just
Ooh.
go straight to our trivia.
Just go for it.
Go for it.
We were talking earlier with NPR about the James Webb Space Telescope, which is getting ready to launch. It's a NASA telescope, but you know what it's launching on?
An Ariane 5, I think,
Yeah.
right? Yeah, which
Yeah.
is a European rocket.
It's their heavy lift vehicle,
Yeah.
and it's basically on its last launches, so
Yep.
they're not going to be doing many more of those.
Yeah.
So the James Webb Space Telescope's this big telescoping, unfolding is what I meant.
Yeah.
Telescope. I guess it'll do telescoping as well.
Yeah.
And it
I
has
hope so.
it has a bunch of mirrors.
Uh-huh.
And these days, most new telescopes are a bunch of mirrors. In the old days, they were single mirror. This is your trivia.
Right.
True.
Yeah.
Oh man, you're not supposed to blurt out the answer until
Shoot.
the end of the show.
Sorry.
So James Webb has. Do you know how many mirrors James Webb has? Free preview trivia question.
Several.
6? 16?
60? 100?
18. Has 18 mirrors that
Okay.
make an effective single mirror. If you were going to get the same thing from a single mirror, it's 6.5 meters. For comparison, the Hubble mirror is 2.4 meters.
Right.
And since it's the area that matters, that's a whole hell of
That's
a lot bigger.
Yeah.
Mm-hmm.
The Giant Magellan Telescope, which is under construction, will have 7 mirrors, 6 of which I think at the moment are done and in place. Each one of its 7 mirrors is 8.4 meters in diameter.
Wowzers.
That's huge.
But this is a ground-based telescope.
It's a ground-based telescope, and it will effectively be like about a 24, 25 meter telescope. We've talked before about the 30-meter telescope proposal, which is not happening yet,
Yes.
at least as far as I know, in Hawaii. So the Giant Magellan Telescope, huge. The question is, how many mirrors are in the largest currently operating telescope? And where is that telescope?
Now, you have to be more specific. Is this visible?
Okay, I will be more
Optical?
specific. So it's visible.
Visible, okay.
Optical, what we call an optical telescope.
Right.
classic-
So radio telescopes
classic
are, of course,
mirrors.
Visible
generally
light
huge.
Please don't
telescope.
use mirrors, though.
And
Well,
also,
they're mirrors for radio light.
No, they're not.
they reflect.
Yeah.
They reflect the radio waves.
That's a mirror.
We don't call them mirrors.
Yeah, I do.
So I'll
Do you
give
look
that
into a radio
clarification.
telescope mirror every day?
It's about the question's about optical telescopes,
The most
and
flattering.
in case there's somebody has made some bizarre thing with a gigantic number of little tiny mirrors in some sort of lab or something somewhere that
yeah.
adds up, those don't count either.
Okay.
So these are let's say that the effective size is of the ensemble thing is bigger than a 5-meter telescope
Okay.
when you put them all together.
All right.
Okay,
I feel like I know this, but it's like right here.
that's your question. I didn't know.
Just off the
I
edge
know
of my
where
head.
it is. I know what it is, but I don't know the number of mirrors.
Okay, what do you know, Jim? Do you know anything about antimatter?
Oh, not as much as I'd like to.
I know. Nobody does.
Yeah, but
That's true.
there's kind of
Well,
not as much as Paul
I
Dirac
don't know.
knew.
Oh.
I probably have met some people who know just about as much about. I think my mom knows as much about antimatter as she wants to.
Okay.
Right, as she
That's
wants
fair.
to.
That's
Yes.
fair.
That's the key part. Yeah.
That was a specific wording.
Yeah, yeah. No, today we're just going to talk for a minute about antimatter in the galaxy.
1 minute, go.
Oh, shoot. There's lots of it. No, there's not lots of it.
Hey, didn't even need a minute.
There you go. No, it
So
turns out there's, so antimatter, of course, we've had this discussion before about antimatter versus matter in the universe as a whole, cosmologically. We figure at the beginning of the universe there should have been equal amounts of matter and antimatter, but obviously in our universe now, it seems to all be matter. So where did all the antimatter go? There must have been some very slight asymmetry in the amount of matter and antimatter in the early universe. And anyway, so now when we look out there, we see
Because matter and antimatter annihilate each other.
Right, that's the fun part, of course, right?
Unless you're Lazarus in the alternative factor Star Trek original series, am I right?
You are right.
Because it is not fun if you're that guy.
Nope.
No,
'Cause
yes.
he met his antimatter counterpart.
Oh,
It didn't go well.
It
It
must
did
not
not.
have
It
gone
went
well.
even worse than you would think.
Really?
Yeah.
How bad did it go?
In order to save the universe from a matter-antimatter annihilation, or maybe not the universe, but
Well, local universe.
he and his antimatter counterpart, who was mentally unstable,
Well,
had to
it's
get
just
sort of
based
like
on normal matter standards.
No, he couldn't deal with the fact that when he discovered that he had a matter duplicate double, sent him off the deep end, and so they ended up having to be locked in a tumbling elevator of space for all eternity somehow.
Yeah.
They
Kinda
made it.
terrifying.
They made it worse than even reality would be. I think.
Okay. Yeah, reality is pretty bad. I mean, because it's like the most efficient way to produce energy that there is to combine matter and antimatter. If you had just 1 gram of each and combined them,
Yeah.
that's a staggering. I mean, that's just like that's a paper clip or something
Yeah.
like that. The amount of energy released in that would be absolutely staggering. It would be considerably greater than the Hiroshima atom bomb.
What's the density of antimatter?
So here's the awesome thing about antimatter: it's essentially exactly the same as normal matter. In fact, I just made the claim that we look out there and we see the universe made up of matter, but we're not actually. You can't be 100% sure of that. If you looked at a star, you would not be able to tell that it was made of matter or antimatter.
So
versus
the
matter.
light that it emits is
Would be
completely doesn't
identical,
care.
right? You could carefully look at the spectrum; it's exactly the same because the physics.
Jim's figured out my secret.
Are
Yeah.
you antimatter?
No.
Ah!
No, while thinking about this, I've decided that my new pet theory, conspiracy theory, is that Oumuamua was made of antimatter, and that's why
the interstellar
visit
/ spaceship.
Yeah, because it had some, the reason
Some
people thought it was a spaceship, it has a
acceleration.
little bit of anomalous acceleration. Maybe it had anomalous acceleration because solar wind particles, which are matter,
Yes.
were hitting it, which was antimatter.
And
Scoot,
annihilating.
scooting.
Giving it a little energy and
Wouldn't
scooting
we
it out.
see gamma rays then?
Yeah, you would. I don't know if we looked at it with
Maybe
the
they
gamma
went
ray.
the wrong direction.
No, it didn't really happen. Fine, it's not real. But I just thought that would
We're
be
getting
a way to get anomalous acceleration, because on the sunward side you'd have more matter hitting it.
I have a question.
Yeah.
How does antimatter work in the flat Earth theory?
Just fine.
Perfect.
But yeah, so
Anyway.
there's not a lot of antimatter out there.
As far as we can tell.
As far as we can tell, the universe is mostly matter, but it is produced in certain radioactive decays. When titanium decays into, I think, calcium, that seems like something that doesn't happen very often.
That's what it sounds. It sounds like something that shouldn't happen.
It
very often.
doesn't happen that often, but it does
But
happen.
statistically,
because
it
it turns out
happens.
that's produced.
What's the confidence interval?
I don't know. I think you gotta pay for the
in-
upgrade for that.
But anyway, so these things, it's out there, and so actually in our galaxy, every second there's something like 10 to the 43 antimatter particles that are annihilating into or interacting with
Really?
matter
That's a lot.
particles. That's a lot.
That's a very big number.
It is a very big number. It turns out our galaxy is very large. The number of total particles in our galaxy is astoundingly large.
Okay.
And so even though that sounds like a big number,
It's not that big.
it's not that big.
Do you know what that is as a fraction of the total number of particles in the galaxy?
No, but it's tiny. I mean, I want to say that they're on the order of 10 to the 80 particles in the observable universe.
Right.
So
Okay.
they're probably 10 to the 60 something particles in our
Okay.
galaxy.
So it's a tiny.
So it's still a tiny fraction.
No,
But
43 is a pretty significant fraction of 60. I'm just kidding. That's not how exponents work.
But yeah, the cool thing is when there is an annihilation, that produces a lot of energy, and so it usually means a photon that's very high frequency, which means gamma rays. And so we can use our gamma ray telescopes to peer out there and see where these things are happening in our galaxy. And it turns out that they're happening more considerably in the bulge of our galaxy
Oh my.
than they are in the disk. And they're spewing out of the bulge, making this cool like fountain of antimatter.
They're spewing out of the bulge, but not out of the disk.
That's
A
right.
galactic gusher. That's the
Okay.
description in one of these pictures.
This could go south quick.
Um,
But that's happening, and we've wondered for a long time why it's happening. I think we have a pretty good idea now, though.
what is it?
I think the idea is it's
Wait a minute. Sorry.
Yeah.
The particles are spewing out of the bulge.
Yes.
Right.
Particles
okay.
we're
Not
detecting.
gamma rays.
No, the particles.
Gamma rays are. But so what? I mean, do we know something about the direction? It's just this whole spewing thing. Is there like a stream of antimatter particles going in a certain direction?
Well, not necessarily a certain direction. They're kind of
It's like a jet coming. It's like if you think of like jets of.
That's what I'm asking.
energy
It's like
from-
yeah.
Yeah.
It's probably
It's a
generally
fountain.
roughly spherically coming out, same in all directions, but it doesn't have an easy time getting out in the disk.
Okay.
So you're going to see puffs above and below the disk.
Okay.
Right. And but no matter where it goes, it can't go that far before it runs into some bit of matter, and so we can detect it by looking at its these gamma rays. So probably the culprit is supernovas. So that's how you want to get your titanium that we mentioned a second ago that is going to radioactively decay.
Yeah. You gotta have. Supernovas.
Then you need supernovas, and not just any supernovas. You need the elusive Type 1 supernovas, or the white dwarf supernovas, where you smash another white dwarf into a white dwarf, and you end up with one of them, with the whole thing going as a big giant thermonuclear explosion, and you produce these cool radioactive elements, which then decay, and as they decay, produce positrons, which are anti-electrons.
Right.
So that's the likely thing. And how they figured that out had to do with, it can't be something that, it can't be like stars birthing or something like that, because then you would find it more in the areas where there's young stars.
Can I object to that verb?
Birth?
Is that what stars do?
They get birthed.
Birthing.
Birthing?
Sure.
Really? I don't
know.
think so.
When I talk about the evolution of stars, I almost always revert to human lifespan.
But isn't birthing when you give birth to something?
I think
Yeah,
so,
the nebula gives birth to... Oh.
So stars aren't birthing. Stars
No.
form.
Yes, stars are born.
They form.
And they form.
The nebular clouds are
They're
birthing the stars.
birthed.
I suppose
Okay.
that's better English.
Yeah. I don't know.
Okay, I'm with that. I'm
Okay.
with that.
In
But
any
anyway,
event,
it has to be. The point here is just that it's coming mostly from the bulge. The bulge is made up of mostly older stars, so it has to be some kind of thing that's associated with older stellar populations and not young stellar populations.
And positrons can stick around for a really long time. So
Well, not really, because they are going to run
until
into
they run
things.
into something.
Right, they're going to run into something.
an electron.
So basically, it means that there has to be something that is being produced by old stars, but old stars are
Not
often
very
white
active.
dwarfs. Are white dwarfs, which, when they collide with other white dwarfs or collide with other things, will
A
produce
supernova.
supernovas. So
Okay, let me ask a question. What happens if a positron runs into a proton?
nothing fun.
Okay,
too
it
fun.
has to run into an electron.
Every particle of matter has an antimatter component, or
And those are
not
the two
component.
that annihilate.
Those are the two. So, but luckily, if you find a proton, you're probably not too far away from an electron.
can
It's
a
probably somewhere
can
else.
a, can a positron and an antiproton they can like merge together?
Oh yeah, they'll make
Yeah,
an anti.
They would make it, but they wouldn't annihilate each other.
No,
they would make an anti-hydrogen.
That would make anti-hydrogen, which would be
Right.
indistinguishable from regular hydrogen.
That's been
unless
done
you
in the
looked at it
lab
closely.
and
Can
for tiny.
Right.
Positron combine with like a neutron, a regular neutron?
Yes. So neutrons.
I'm trying to make weird mixed matter.
A neutron
Yeah,
plus a positron is plus some other stuff probably gives you a proton.
We need to play Kit Cowell's game so I know these
That's right.
things.
Yes. Yeah.
I mean,
Collider.
I have spent lots of time in my life dreaming about the cool things that you could do with antimatter. If I could just get
sorry
my
to hear
hands
that.
on some.
That sounds pretty fun.
Um,
You should talk to some
yeah,
sci-fi
I'm
people.
sure we've talked on the program before about my sweet take over the world scheme with the.
No.
Yes, I think we have.
I don't know if we should talk about it on the program.
yeah.
Do you want
All
people
right,
to
we'll
know?
wait for next
we
program.
don't want somebody else to take
Do you
your
want
idea.
somebody else to
Oh,
take
it's
it?
such a good idea. We're going to totally rule the world
Okay.
All right.
next time
Interesting.
on the next episode.
With our walkabout crew.
All antimatter related.
All right.
Mm.
Well, our other science lab is a little closer to home.
Yeah, it's all about sturgeon.
Oh yeah. What is the deal with the sturgeon?
What is the deal with the sturgeon?
Sorry, listeners. This is mostly an inside joke.
Great.
He
Nothing-
wanted to
Nothing
spend.
people love better
Yeah,
than
I
so
said-
listening
on a
to somebody
podcast.
else's inside joke.
On his birthday, maybe, I sent Jim an article, it was maybe the day after, about this awesome discovery in the Detroit River of a giant sturgeon that's like 100 years old.
How giant?
Bigger than a human, like longer than the height of a human. There was a
Is
human
that,
laying next
is
to
that
it.
unusual? I thought sturgeons were generally
It's very
giant.
unusual in that area.
Okay.
Yeah, sturgeon are some of the largest, probably the largest freshwater fish in the world. There are, of course, many different species. They got huge ones out in Lake Baikal and stuff from Russia, and they get all
Oh,
that
yeah.
sweet Russian caviar and so forth. And we even have them down here in Florida in the Swanee River,
Really?
and in the Gulf of Mexico. Different things.
Can we
but
get
yeah.
caviar from them too?
You can,
Yeah. Well,
but they're protected. in Florida.
And they can live for a really long time.
They get really
This
old.
one
They're
was over 100
prehistoric,
years.
weird-looking ones, and they were, I mean, they do get huge. But of course, the Detroit River, I don't think it's not clean. It's not nice. And so,
very
finding
industrial
a huge
area.
one there, I think was cool.
is
Anyway,
that sturgeon still alive? Or
It is still alive, yeah.
Okay.
I think they tagged it or something and put it back.
yeah,
It was the
Okay.
picture was in the boat, but I don't think they killed it. It was 100 years
yeah. I
old.
think they were doing like electrofishing, right? There's like
okay, people would
sampling.
never kill
Yeah.
something that
They
was
were
100 years
that's
old.
true. No, they were sampling as like a typical study they do of the
I
river,
see.
and they were
Okay.
like
This is a
the
very
other
big
biggest thing
fish.
we found was a bucket.
Right. Okay. Well, the commander of the Messiah mission in Deep Impact was Sturgeon Tanner.
Ooh,
Oh,
And
yeah.
his
That's
nickname
true.
was Fish because of the similarity of
Look at
Sturgeon
that.
to Sturgeon.
There you go, a connection.
We got it.
Bringing it back to
Tie
me.
it all.
All right. So
together.
what, so what is this closer to Earth?
Well, Saturn.
Saturn
Oh.
is closer to Earth than
Yes.
the galactic.
than the
bulge.
galactic bulge. Yeah, absolutely.
One of the cool discoveries made by Cassini at Saturn was that there are waves in Saturn's rings that are caused not by gravitational perturbations from Saturn's many moons, of which there are many of those waves, which we knew about and discovered many more. But there are a bunch of waves that are caused by oscillations called modes, normal modes, in the planet itself.
Yeah.
So an uneven distribution of matter in Saturn can act as a gravitational perturbation to the particles in the rings.
Jiggles around.
And if you're at a particular orbital distance from Saturn relative to where that uneven distribution of stuff is inside the planet and how fast it's rotating, their wave will be launched there. So like by looking at these waves in the rings, saying exactly where they are and how many spiral arms they have, because they're spiral waves like the Milky Way, but like super, super tightly wound.
Mm-hmm.
You have to
Just like you.
Figure out, that's right. You have to figure out how many spiral arms they've got and where they are. You can learn something about the internal structure of the planet.
It's pretty cool. It's called chronoseismology,
Which is an awesome.
which I think is awesome.
That is insane. I'm very impressed that people are able to kind of reverse
Figure that
engineer
out?
that, dig out that information from there.
Yeah.
Yeah, I remember seeing a talk
impressive.
about it 10 or so years ago. I was just like,
Yeah.
whoa.
Back in the Voyager days, they had seen a few of these waves and had hypothesized that this is what they were caused by. We didn't have the quality of data that we got from Cassini. Now we've seen many, many more of those waves, and allows you to put together a mapping, because you would expect to see multiple waves from particular of these so-called modes inside Saturn. So if you think about the interior of Saturn as a gas giant, it's mostly gas, but it has a solid interior.
Mm-hmm.
And so the distribution of density as you go out and the rates of rotations, and then also the sort of natural frequencies of the stuff. So if you imagine going up to Saturn and flicking it
I'd do that.
and seeing how it sort of bounces back.
Yeah, I just picture
on
like
you.
a thing of Jello.
That's right,
like,
yeah.
boing.
Think of it as
Yeah.
a cup of Jello or something like that, and you would see ripples,
Yeah.
and sort of the frequency of those ripples and the speed that they propagate and the number of those. You can imagine also like hitting a drum and you sort of get maybe standing waves, but how many? Do you get 2 lobes or 4 lobes or 8 lobes? And
Then
how are they
frequencies.
distributed in this whole three-dimensional planetary environment? And all of those different things control what these waves end up looking like. So, yeah, as you say, they reverse engineer that stuff.
That's pretty
and
cool.
so
It's amazing.
It is, yeah. And so
And it's cool that we can see it because Saturn's rings are there,
that's right,
right? You can't really see the stuff in the atmosphere
right.
of Saturn, and you wouldn't be able to just see it if there were like just some moons there.
That's right.
And like gravity has, or Jupiter has this thing happening, but like its rings
Right.
are so diffuse that we probably can't see
Yeah.
it there.
Yeah.
Thanks, Saturn's rings.
Yeah.
Saturn's rings they're very cool, sort of like seismometer
Yeah.
paper
Yeah.
with a little sensitive needle.
Yeah,
Right.
exactly.
And so they're telling us a lot of stuff about other things besides themselves. And so scientists have studied this in a new paper that's come out. And I should just backtrack just a second and say that the Juno mission at Jupiter sort of trying to understand the same sort of thing by looking at the motion of the Juno spacecraft itself
Yeah.
as it
Right.
orbits Jupiter. Now we're using the orbits of all these
Yeah,
countless
tiny particles.
particles in Saturn's rings to sort of get some of the same information. So it turns out that Saturn's core may contain as many as 17 Earth masses of solid stuff, ice and rock,
Oh.
which is a little bit
That's a
on
little
the
more
high
than I
side.
Higher.
thought.
If we would have guessed,
We
we might
usually
have
say
guessed
like
lower.
5 to 10, right?
Yeah.
I would have said, yeah,
10-ish.
10 was the number I
Carry
have in my
around.
head.
17 Earth masses, and that
This is
the
gonna get you.
core envelope transition region is 60% of the planet's radius out.
That's crazy.
Hmm.
So it's like,
It's pretty big.
so it's
in
more
other
mass
words.
than we thought, but like probably
kind
also
of
sort of
spread
spread out
out
more, so maybe
than we
not
would
quite
have
as
thought.
compacted.
And so, so it's got this sort of fuzzy boundary
Yeah.
there. And it's a very complicated interior. This doesn't put the final word on what the structure of Saturn's interior is like. We tried with Cassini to do the same thing that Juno is doing, of sort of tracking Cassini as it flew by Saturn, and in the end, they couldn't really fit the measurements. They had to say, something else is going on there.
Oh, interesting.
Yeah, they didn't have as many flybys
Yeah.
as Juno does, but their basic assumption going in is, let's pretend or assume Saturn is like Jupiter, and then we'll be able to figure all this stuff out. And then it turns out not so
not
much.
like Jupiter.
It's more weird than Jupiter.
Nice.
So it's just
Cool.
it's another thing of figuring out stuff you can't see
Right.
correctly
Yeah.
from all that stuff. Speaking about seeing stuff,
Oh.
you know, I used to see stuff.
Mirrors.
Yes.
But not- yeah, sometimes you use radio telescopes to see stuff.
Mirrors and radio telescopes.
Those are the
Completely
only
different things. So,
I'm gonna get Jim a radio mirror for his birthday.
Yes. I would look a lot better in a radio mirror than I do in a regular mirror.
Yeah.
It's
It's like 1 pixel.
I could be pretty in 1 pixel.
how many mirrors are in the biggest, most mirror telescope for optical visible light? And where is that telescope?
So
I've told you, I have revealed that the James Webb Space Telescope has 18. It's
18.
not yet in place, but it will be launched
yeah.
later this year
Yes.
to Earth's L2 Lagrange point. And the Giant Magellan Telescope, which is not yet commissioned and running, to my knowledge, it's not fully open, will have 7 humongous mirrors.
I think it is in the Canary Islands. I think this is
Oh.
a big telescope
Okay.
on a big volcano in the Canary Islands.
Mhm.
And I think it's 10.2 or 10.4 meters. I can't remember.
Okay.
And I'm gonna guess. I have no idea what the number. I'm gonna guess 24 mirrors.
Okay.
I'm gonna guess 33 mirrors.
Addie wins,
Nice.
but she's
But I'm
still
low.
way off.
Yeah.
The answer is, in fact, 91.
Whoa.
And it's a tie.
It's a tie.
It's a tie.
Is it between the two Geminis?
No.
Oh.
There are
'Cause
two
those are not-
telescopes with 91 mirrors. The Southern African Large Telescope,
Oh, SALT.
or SALT.
Amanda
and-
Sickafus works there.
That's right, my former student. And the Hobby Eberly Telescope at the McDonald Observatory.
That's the one I was thinking of.
In the middle of nowhere, Texas.
Because I've been there.
Which is, coincidentally, not too far from
Where Blue Origin launches.
Blue Origin's West
Yeah,
Texas
so I was
launch
thinking
site.
of that. I was like, I've been to this display where they showed all these mirrors in this telescope that had tons of mirrors, and it was at the McDonald Observatory. But I was like, but it's not that telescope. What telescope is it?
So
Yeah.
I guess I was
It's super
confused
cool.
about the nature of the question. I mean, I certainly
Were you?
Oh,
Are you
not
looking
about the
at
number.
the
No, not
mirrors?
about the number of mirrors. Part.
I was
Like,
pretty clear about the question.
I thought you were asking what is the biggest optical telescope in the world.
That was not the question.
That was
Question
so
was
clearly not
most
the
mirrors.
question.
That was part. I got confused.
No, I said that.
It wouldn't have changed my answer for the number of mirrors at all. I have no idea.
I didn't know it was 91. That's impressive.
Yeah, that's crazy.
Yeah.
Are they the same design?
Their individual mirrors are 1 meter each.
Does
so
the two
they must be
telescopes
very,
the same designs?
I don't know.
Oh.
Between those two, their component mirrors are the same size, and they have
Okay.
the same number of them. But the effective area listed is a little bit different between the two. Each about 10 meters. And you're right, the Grand Canary Telescope is about that same size, also about 10 meters, but it's using a smaller number of larger mirrors. A
Fair
number
enough.
which I'm not identifying immediately here.
Gotcha.
There you go. The Large Binocular Telescope has a larger effective aperture from, guess how many mirrors?
2.
Yes!
You should know about the Hobby Everly because they do a cool like dark energy experiment with it.
Do they?
Yeah, I remember that.
Yeah.
I learned a few things when I went to that telescope. We got to drive one of the other telescopes.
Each of the
Dave
two,
enjoyed
you,
it.
you guessed 34 or 36.
I think I said 33.
The Keck telescopes each have 36. So,
That's what I was thinking of.
yeah, in any event, there you go.
I keep wanting them to have some nice number like 1664 kind of thing, but I guess that's not the case. I guess you
No.
can kind of design it to have even or odd or whatever.
Yeah. The shapes of these are they're not like
Usually
arranged
not
in a
a
perfect
circle.
circular, they're
Yeah.
somewhat oval.
Right.
That probably has something to do with gravity.
They're also often not oval even. They're like hexagons
They're,
and stuff.
Yeah.
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 So they're
Pentagons.
individually controlled by computers and actuators to constantly be correcting for things. So, like, for example, the Giant Magellan Telescope, which will be the largest effective area when it opens, 25-meter telescope, will have 10 times better resolution, I think, than Hubble,
Wowzers.
because it's able to compensate for all the blurring that the atmosphere
Right.
does
Right.
by constantly shifting these mirrors.
That's
by tiny
unbelievable.
amounts.
That's called adaptive optics, and
It's insane.
it blows my mind.
Yeah.
Because you have to change the shape of the overall mirror faster than
Then the
the light
atmosphere
is bouncing
Atmosphere is,
around.
yeah.
So you're making
Changing it,
many
right.
corrections a second to the
Yeah,
shape, or not. It's insane.
it is very impressive.
I'm very impressed. But it's great because, yeah, like you said, it allows us to have better resolution from Earth. I mean, don't get me wrong. If you had the same size telescope in space, it would
It'd
give
be
you better
better,
resolution than the same
Right.
one on Earth. But
and
to get space telescope kind of resolution from Earth, we thought we were at like the maximum you could get from Earth,
right,
and that's why we like stopped building telescopes at about 10 meters, because we were like, if you build them bigger, it's not going to help you much,
blurry.
right? Because everything's blurry because of the atmosphere. But now with this adaptive optics, we can go and take that next step and build these monster 25, 30, 100-meter telescopes, whatever.
Of course, since we mentioned James Webb, it's worth reminding everybody that there's another gigantic advantage to being in space besides the resolution problem of the atmosphere, which is that the atmosphere literally prevents a lot of light from getting down to the surface.
And you
at
don't
all.
always have people poking it.
Right. And that's the thing with infrared, right? Not the poking thing, but but the fact that infrared light does not easily get through the Earth's atmosphere. It's absorbed by water and things
So
like
you
that.
just can't see that stuff at all.
Can't see that stuff
I
at
don't
all,
care
so-
what your telescope is like, or
Right.
how adaptive the optics are, or anything like
Right.
that.
Yeah.
It might as well have a lens cap on it.
Exactly.
Can't you just put a cloud filter on it?
With the cloud filter.
But,
That's a
Yeah.
classic telescope joke.
Yes. Yeah, well, I faced that when I was a TA at the observatory, and it was raining, and people came in. It's like, well,
I'm like, can we see?
you've got a telescope, though. I don't understand why
It
they
See
do
right
appears
through
through,
them.
the
I'm
atmosphere.
like,
Yeah.
it's cloudy. Well, it may have felt like the time to travel to interstellar space. It was just another episode of Walkabout the Galaxy. Write us a review in the binary language of moisture vaporators and get C-3PO to spread it around the outer rim.
Oh.
It was Star Wars Day this
Yeah,
week.
may the force be with you.
Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel, where you can see most of our episodes, some of our bloopers, and all of our music videos. There's just one. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Thanks to our listeners in Alaska and around the world. Stay safe. I'm Lee Byung-hun.
I'm Addie Dove.
And I'm Jim Cooney.
Amory just wishes I was.
Yeah.
My wife just wishes I was. I'm Josh Cole. We're the Astroquarks, signing off until the next episode of Walkabout the Galaxy.
Together we make one decent human. What was it?
That's one
Reasonable human?
Reasonable.
Reasonable human.